I mentioned this a couple of times in other videos about compound interest, and I think it's important I talk about just a little bit more. What I'm going to say here, though, is completely optional. I don't want to confuse you, and so if you're worried it's going to confuse you, and just ignore this video. If you found it helpful, let me know. If you're taking finite math with me through ICCOC, you probably have a different formula for compound interest than if you were taking finite math with me in just through Iowa Lakes. And that's because your textbook uses a different formula, which is also then integrated into its version on MyMathLab. And formulas in general, while some formulas are very common and they're identical, other times different textbooks just have different ways of writing formulas. Normally that's not a big deal, but compound interest is done so often that it actually is kind of unusual that your textbook does it the way it does, I think. When I look at other videos on YouTube, when I look at other sources, most of them use the much more traditional formula. I think your textbook does this because they think it's going to make it easier down the road, and it does in some cases, don't get me wrong, but it's hard to it's hard to relate it to other outside sources then. So I just want to talk about the sort of what I'm going to call the traditional formula, by which I just mean it's what most sources use right now, and your textbook's formula. So first, your textbook's formula that we've talked about in class before is this for compound interest. It's the future value A is the present value P times the principal, sorry, P times the quantity 1 plus I to the N. And I is the interest rate divided by M, where M is the number of times it's compounded each year. And so what I did is I just made up a problem. I have $2,500 to deposit. I'm depositing in an account that pays 8% compound interest. The interest is compounded quarterly, and I'm keeping in this account for 12 years. So I'm going to plug those values in here. So my future value A would be $2,500 times 1 plus I is 0.08 over 4 because it's 4 times a year. And then N is going to be 4 times 12 or 48. So hopefully if you looked at my other compound interest video for your textbook online, this looks familiar to you, that it doesn't surprise you at all. I know I went a little quicker here than I did in that because it's not designed specifically to teach you the formula. It's just designed to explain how these two formulas look similar, because they are the same formula. You'll get the same answer either way. And so let's put this in the calculator. 2,500 times 1 plus 0.08 divided by 4, because it's quarterly, to the 48. And it's 48 because it's 12 years times 4 times a year, and 12 times 4 is 48. So at the end of 12 years, I'll have a nice chunk of change in the bank. At the end of 12 years, my future value A will be $6,467, and if the bank is nice and rounds up, 68 cents. Not bad. Now let's use the formula that you're going to see from other sites, that you're going to see if you look at some of the optional videos I put up on the course page to help you if you're having issues. Or the formula that you probably learned if you took math for liberal arts. Certainly, if you took math for liberal arts at Iowa Lakes, you learned this formula. If you took math for liberal arts online at ICCOC, you also learned this formula because they use the same book, or at least they have up until this point. So that other formula is future value is P times 1 plus R over N to the N times T. And hopefully you can see already there's a lot of similarities here. What your book tries to do, I think, by using I, is it tries to simplify the formula. And I think by trying to simplify it, they actually make it more complicated in the long run. But that's just my thought. I might be wrong. But we can do the same thing here, then we'll plug in our values. So our values are that A equals 2,500 times 1 plus our interest rate, 0.08, n is 4, and then up here, n is 4 times t is 12. And so hopefully you can automatically see that these two things equal each other, because 4 times 12 is 48. So clearly I'm going to get the same result either way. So I share this with you just so you recognize that you're going to see this other formula used much more commonly. Again, if you go Google compound interest formula, if you look on YouTube or some other video source for compound interest formula, you're probably going to see the formula on the right that I just circled. That's, I think, much more commonly taught. Your textbook just does a different approach to it for its author's own reasons, and I'm sure they have valid reasons to them. I don't like the approach personally, but that's just me. It's fine if you do. So I just want to share this just so you recognize that there's a lot of similarities here, but also that textbooks and other sources sometimes just change how things look. This is going to be important a little bit later in the course when we talk about matrices and working with them, um, and when we talk about simplexes. Because there's lots of different ways to do that, and you're going to see a lot of different variations as well. So we have some variations in math representing just individual interests. So I hope this was interesting for you. I'm not sure if it was helpful or not. If it was, let me know. If it wasn't, just ignore it. Have a great day.